We are going to study now allotrophic forms of sulfur, sulfur dioxide, sulfuric acid, preparation, properties and uses, and structure of oxo acids of sulfur. Rest of the lesson repeat.
Allotrophic forms of sulfur. We already learned allotrophic forms of phosphorus. Here allotrophic form of sulfur. It contains two forms. One is crystalline form, another one is amorphous form. Crystalline means inside the crystalline form the sulfur molecules are arranged in regular manner. And amorphous form means the sulfur molecule inside the sulfur molecule are arranged in irregular manner. The first one, crystalline form, there is two form. One is rhombic sulfur, that is alpha sulfur. Another one is monoclinic sulfur, that is beta sulfur. Among these two, the rhombic is a very stable one. We will see later. And amorphous form, there is three types. One is plastic sulfur, that is gamma sulfur, milk of sulfur and colloidal sulfur. The first one, rhombic sulfur, it is a very stable one at ordinary temperature and pressure, and it has the color yellow color, and it contains S8 molecules. When it is heated above 96 degrees Celsius, it slowly converted into monoclinic sulfur. Again on cooling below 96 degrees Celsius, the monoclinic sulfur, that is beta form, converted into alpha form. What is alpha means? Rhombic sulfur. The next one, monoclinic sulfur. That monoclinic sulfur, what is the difference between rhombic and monoclinic means? The rhombic sulfur, it contains only S8 molecule, but monoclinic sulfur, S8 molecule and addition to small amount of S6 molecule. And it another name for monoclinic sulfur, already we know that it has beta sulfur, but another name prismatic sulfur. Why we called it prismatic sulfur means it is a needle like prism, so that we called as prismatic sulfur for monoclinic sulfur. And it also stable between the temperature 96 degrees Celsius to 190 degrees Celsius. Afterward it slowly changes into pale yellow liquid, and on cooling it slowly changes into rhombic sulfur. The first one, when molten sulfur is cooled into cold water, a yellow rubbery ribbon. Rubber means what form? It is a amorphous, so we get the plastic sulfur. So how we get the plastic sulfur means when the molten sulfur is cooled into cold water, we get the yellow rubbery ribbon, and it is a very soft one. So rubber means what you do with the rubber? It's stretched, so it is stretched easily. On standing, it is also changed as a hard one. First of all, it is a soft one, but on cooling it is changed into hard one, and it is also changed to stable rhombic sulfur. The next one, sulfur also exists in a liquid and gaseous state. We already told that monoclinic sulfur at it is stable 96 degree to 119 degree, but above 140 degrees Celsius the monoclinic is changed into mobile yellow liquid, that is called as lambda sulfur. The vapor form of liquid sulfur that contains S8, S7, S6 and also a small amount of S2, S3, S4, S5 molecule. Preparation of sulfur dioxide. First preparation from sulfur. It is a large scale production. The sulfur on burning with oxygen, it gives sulfur dioxide, but 6 to 8% of sulfur it oxidizes to give sulfur trioxide, but most of the percentage we are getting as a sulfur dioxide. The next one, from sulfide ore. For example, galena and zinc plant. Galena means lead sulfide and zinc plant means EZNS. On burning, that is roasting in air, we get sulfur dioxide is the one of the product. In this production, the sulfur dioxide is mainly used for preparation of sulfuric acid. The next one, for example, EZNS reacted with oxygen gives EZNO plus sulfur dioxide. The next reaction, FeS2, name of this compound is iron disulfide. On reacting with the oxygen on heating gives ferric oxide Fe2O3 plus sulfur dioxide. The next preparation is laboratory preparation. In this laboratory preparation, metal is treated with the sulfuric acid, it gives one of the product as sulfur dioxide, and another one, metal sulfite is treated with the sulfuric acid, it gives sulfur dioxide is the one of the product. The first one, copper with sulfuric acid, it gives copper sulfate plus water, 2 moles of water. Along with that we get sulfur dioxide is the one of the product. The next one, sulfite, metal sulfate. We are going to take the sulfite alone. SO3 minus is called as sulfite ion. Then in sulfuric acid, the acid means always gives H plus ions. So we from sulfuric acid we are getting 2 H plus. In this 2 H plus it gain one oxygen minus from SO3 minus, so that it produce water, and remaining things we are getting as a sulfur dioxide. Next one, physical properties of sulfur dioxide. Sulfur dioxide is a gas and it is found in volcanic eruptions, and most of the power plant like coal plant, oil plant, copper melting plant, they released the sulfur dioxide gas in large amount in atmosphere, and it is a colorless gas. It has a odor, suffocating odor. What is suffocating means, in that gas we can't easily breathe. It is difficult to breathe. The next one, chemical properties. Sulfur dioxide is the oxide form of sulfur and it is an acetic oxide. Then why it is called as acetic oxide means, in water it produces sulfurous acid. So it producing acid, so that it is called as acetic oxide. And then the sulfurous acid is a weak acid and also it is a dibasic acid. Why it is called as weak acid means, acid means always giving H plus, but here they give H plus, but again that H plus combined with the SO3 2 minus, it gives again sulfurous acid. So it is a equilibrium reaction, so that it is called as weak acid. Strong acid means they never combine with each other, give the acid. That is called as strong acid. But here they decompose and gives the H plus. Again the H plus combine with each other and gives the acid once again. So that it is a weak acid, and it is a dibasic acid. Why it is called as dibasic means, it gives 2 H plus ions. So that it is a dibasic acid. The next one, the sulfur dioxide when react with the sodium hydroxide, it gives sodium bisulfate. See the first reaction, SO2 plus NaOH, sodium hydroxide, it gives NaHSO3. But on reacting with the sodium carbonate with water, the sulfur dioxide gives sodium bisulfate along with the carbon dioxide gas. Please remember one thing, sodium carbonate, the carbonate salt always give the carbon dioxide is the one of the product. Here also the carbon dioxide is the one of the product. And here we are getting 2 moles of sodium bisulfate. The 2 moles of sodium bisulfate once again decomposes as sodium sulfide and water, and it produces sulfur dioxide once again. The next one, oxidizing property. The sulfur dioxide oxidize the other compound. First one, see that the hydrogen sulfide. The hydrogen sulfide contain hydrogen. In product side, the hydrogen sulfide now changed as a sulfur. We are going to remove the hydrogen. So removal of hydrogen also called as oxidation. So here sulfur dioxide used to remove the hydrogen from hydrogen sulfide. So it oxidizes the hydrogen sulfide to sulfur. Here we are getting water as the one of the product. The next one, magnesium. Magnesium on reacting with the sulfur dioxide, magnesium is changed as a magnesium oxide. That is, magnesium is added with the oxygen. So addition of oxygen also called as oxidation. Here the sulfur dioxide oxidizes the magnesium to magnesium oxide. So it is called as oxidizing agent. Reducing property of sulfur dioxide. Here see the reaction. Sulfur dioxide is reacted with the water in presence of chlorine. The chlorine is changed as a hydrochloric. Then the remaining things, water and sulfur dioxide, changed as a sulfuric acid. The chlorine, please concentrate on chlorine. Chlorine is changed as hydrochloric. That is, chlorine is added with the hydrogen. So addition of hydrogen is called as reduction. So here the chlorine reduced to hydrochloric acid. That reduction action is undergo by with the help of sulfur dioxide. Here the sulfur dioxide is used as a reducing agent. The next one, in KMnO4, in the presence of sulfur dioxide in water, it gives potassium sulfate, manganese sulfate and sulfuric acid. Please concentrate on the oxidation number. KMnO4 Mn oxidation number is +7, and manganese sulfate manganese oxidation number is +2. So oxidation number is reduced, that is decreases, so that it undergo reduction with the help of sulfur dioxide. The same way, potassium dichromate, chromate oxidation number is +6, and that chromic sulfate, here the chromium oxidation number is +3. So +6 to +3, the oxidation number decreases, so it undergo reduction. Potassium dichromate reduces to chromic sulfate with the help of sulfur dioxide. So here also sulfur dioxide is act as a reducing agent. The next one, the sulfur dioxide reacted with the oxygen on heating at high temperature in the presence of vanadium pentoxide, that is 450 degrees Celsius, it gives sulfur trioxide. It is an important process. Process name is contact process. The next one, bleaching action. Bleaching means what is that? The color of the substance it made into colorless, that is called as bleach. The bleaching action of sulfur dioxide in the presence of water because of its reducing property. Reducing means what? It reduces the other compound. Now see that the sulfur dioxide plus water, it gives sulfuric acid and 2 NUS and hydrogen. These 2 NUS and hydrogen is reacted with the colored compound. It is added, the hydrogen is added with the colored compound. So addition of hydrogen is called as reduction. The reduction is undergo with the help of sulfur dioxide, so it is called as reducing action. It is undergo with the help of sulfur dioxide, so it is called as reducing property of sulfur dioxide. So bleaching action is why it is happening means because of reducing property of sulfur dioxide. Then once again the bleaching product is allowed to stand in air. Again it regain the atmospheric oxygen, so that it gain the original color. So the bleaching action of sulfur dioxide is a temporary action only, it is not a permanent one. Next, sulfur dioxide, it is used in bleaching and in disinfectant. The next one, structure of sulfur dioxide, then it is has the sp2 hybridization. Now see the structure, it is one of the bond is double bond between sulfur and oxygen. It is because of p pi. P pi means we get the p orbital from oxygen and d orbital from sulfur. P pi d pi overlapping of p pi of oxygen, d pi of sulfur overlapping, only we are getting double bond character. Then you see that in oxygen atomic number 8, electronic configuration 1s2, 2s2, 2p4. In sulfur atomic number is 16, 1s2, 2s2, 2p6, 3s2, 3p4. In 3, if the orbit is 3 means it contains 3d also. So in oxygen there is no d orbital, but in sulfur there is d orbital. So the double bond formation is p pi of oxygen and d pi of sulfur overlapping we are getting. The next one, the oxygen, if it contains single bond means it has 3 lone pair along with the negative character. The same way, suppose oxygen has double bond means it contains 2 lone pair. Now see the first structure. In first oxygen it contains 3 lone pair along with the negative character, but second oxygen it contains double bond along with the 2 lone pair. The same way in this another structure, first oxygen containing 2 lone pair and double bond, and second oxygen it contains single bond along with the 6 lone pair. And also it has the negative character because it gained the electron from the sulfur. Sulfur also has the same manner with the oxygen because it is the family of oxygen. Sulfur also one of the member of the oxygen family. The same way sulfur contains double bond character and then 2 lone pair electron, or sometimes it contains single bond and 6 lone pair electron. It gives the lone pair to the one of the oxygen, so that it possesses the positive character. In both the structure, the sulfur possesses positive character. Next, preparation of sulfuric acid. The sulfuric acid is prepared by the chamber process, cascade process, or contact process. In this chapter, we are going to see the contact process. The first step, the sulfur dioxide is produced by burning sulfur with oxygen or iron pyrite in oxygen. Sulfur plus oxygen gives sulfur dioxide. Then iron pyrite means FeS2 plus oxygen gives ferric oxide along with the sulfur dioxide. In the second step, sulfur dioxide is again reacted with oxygen in the presence of vanadium pentoxide or platinized asbestos. It gives sulfur trioxide. Then third step, the sulfur trioxide is absorbed by concentrated sulfuric acid. It gives H2S2O7, that is it is called as oleum. Again that oleum is converted into sulfuric acid by adding water. We get 2 moles of sulfuric acid. If you want more sulfuric acid means we have to maintain some condition. What are they means 2 bar pressure and 720 Kelvin we have to maintain, then only we get the maximum sulfuric acid. And also we get 96% of pure sulfuric acid in this method, that is contact method. Physical properties of sulfuric acid. Pure sulfuric acid is a colorless. It has high boiling point and viscosity because of hydrogen bonding. Because of hydrogen bonding only it has high boiling point and high viscosity. The second one, dehydrating agent. Sulfuric acid is used as a dehydrating agent. What is the dehydrating? D means removal, hydrating means water. Removal of water. So we are using removal of water sulfuric acid because sulfuric acid it strongly attract the water. So it has strong affinity towards water. When it is dissolved in water, the sulfuric acid gives two addition compound. First one, sulfuric acid contain 1 mole of water, that is called as monohydrate. In second one, sulfuric acid contain 2 mole of water, that is called as dihydrate compound. And this reaction is a exothermic reaction. It gives large amount of heat evolving. The next one, dehydrating property. It is an important question, girls. First one, sugar. Sugar is sucrose, C12H22O11. When it is added with the sulfuric acid, it attracts the water, 11 moles of water. So it gives 12 carbon and sulfuric acid with 11 moles of water, one of the addition compound. The next one, formic acid. Formic acid formula HCOOH. Here we are going to remove water. So remaining one, CO. CO is evolved and 1 mole of water is added with the sulfuric acid, 1 monohydrate, sulfuric acid monohydrate we are getting. The next one, oxalic acid formula COOH twice with the sulfuric acid. Here carbon monoxide and carbon dioxide is eliminated and 1 mole of water is attracted by sulfuric acid. Chemical properties. Sulfuric acid is a highly reactive one, we know very well. It is the strongest acid as well as oxidizing agent. First one, it is a stable acid, but it stability is broken at high temperature. At high temperature, it decomposes as water and sulfur trioxide. Sulfuric acid, acidic nature of sulfuric acid. It is a strong dibasic acid. Why it is called a strong dibasic acid means it form two types of salt. One is sulfate, another one is bisulfate with the bases. First one with sodium hydroxide. Sodium hydroxide is split into Na plus OH minus and sulfuric acid split into H plus HSO4 minus. So H plus goes to OH minus gives 1 mole of water and Na plus goes to HSO4 minus gives sodium bisulfite. NaHSO4 is called as sodium bisulfite. It's one of the salt. The next one, suppose the sulfuric acid is reacted with the 2 moles of sodium hydroxide means that is gives sodium sulfate and 2 moles of water. Here you split the sulfuric acid as H2H plus and SO4 2 minus and the sodium hydroxide split into 2 Na plus 2 OH minus, so that we are getting sodium sulfate along with the 2 moles of water. The next one, ammonia. Sulfuric acid is reacted with the weak base ammonia. We get we get ammonium sulfate, NH4 twice SO4. The next one, oxidizing property. Sulfuric acid oxidize the other element So how it is oxidize other element means the first reaction, see that the sulfuric acid gives water, sulfur dioxide along with the Nessen oxide. This Nessen oxide is responsible for the oxidation of the other element. So first three reaction, you see that carbon, it is oxidized to carbon dioxide with the help of sulfuric acid. So we get the other byproduct or sulfur dioxide and water. You see that on all the reaction we are getting sulfur dioxide, water, but this which compound we are going to oxidize only we are going to concentrate. The next one, sulfur. Sulfur is oxidized with the help of sulfuric acid as sulfur dioxide. Here we are going to add the oxygen. So that addition of oxygen is called as oxidation. The third one, phosphorus. Phosphorus is oxidized to phosphoric acid. H3PO4 is called as phosphoric acid. Here also we are getting sulfur dioxide and water as a byproduct. The next one, next three reaction, we are going to remove the hydrogen. So removal of hydrogen also called as oxidation. Hydrogen sulfide. Here the hydrogen sulfide, remove the hydrogen mean we get sulfur. So here also it is oxidized sulfur. Hydrogen sulfide is oxidized to sulfur with the help of sulfuric acid. The next one, hydrogen iodide. Hydrogen iodide, the hydrogen is removed so that it is changed as a iodine. So here also hydrogen iodide is oxidized to iodide with the help of sulfuric acid. The next one also, hydrogen bromide is oxidized to bromine with the help of sulfuric acid. Reaction with the metal. Sulfuric acid reacted with the metal, different type of sulfuric acid, that is dilute sulfuric acid reacted with the metal, it gives removal of hydrogen takes place and then it gives salt. For example, zinc. Zinc reacted with the sulfuric acid, it gives zinc sulfate salt along with the removal of hydrogen gas. The next one, aluminium. Aluminium also reacted with the sulfuric acid, it gives aluminium sulfate and evolving hydrogen gas. Then hot concentrated sulfuric acid, it reacted with the metal, it gives the different product. That concentrated sulfuric acid gives sulfur dioxide gas along with the water. You see that in the first one, copper with the sulfuric acid, it gives copper sulfate salt along with the water and sulfur dioxide. Then another one, lead. Lead is reacted with the sulfuric acid, it gives lead sulfate plus water plus sulfur dioxide. So dilute sulfuric acid means it gives hydrogen gas, but hot concentrated sulfuric acid means it gives water along with the sulfur dioxide gas. Please remember this one. The next one, sulfuric acid does not react with the noble metal like gold, silver and platinum. And that sulfuric acid react with the metal salt, it gives sometimes sulfate, sometimes bisulfate. Let's see the example. First one, potassium chloride salt is reacted with the hydrogen sulfuric acid. Split the sulfuric acid as H plus HSO4 minus and potassium chloride as K plus Cl minus. So K plus reacted with HSO4 minus gives KHSO4 and then H plus reacted with the Cl minus gives HCl. The same way in potassium nitrate, split the potassium nitrate K plus NO3 minus. In sulfuric acid, H plus HSO4 minus. So K plus reacted with HSO4 minus gives KHSO4, that is potassium bisulfate, and then H plus reacted with the NO3 minus gives HNO3. The next reaction, sodium carbonate reacted with the sulfuric acid. Please remember, always carbonate salt gives carbon dioxide as a one of the product, and here the sulfuric acid attract the water also, so that water is the one of the product, and along with the salt, sodium sulfate. The next one, sodium bromide reacted with the sodium sulfuric acid, it gives sodium bisulfate is the one of the product and evolve the sulfur dioxide gas, bromine and water. The next one, reaction with the organic compound. Benzene is the organic compound. When the benzene is reacted with the sulfuric acid, it gives benzene sulfonic acid. We have already learned in 11th standard along with the water. The next one, uses of sulfuric acid. The sulfuric acid is used in the manufacture of fertilizer, ammonium sulfate, superphosphate and also hydrochloric acid, nitric acid. The second one, it is used as a drying agent. We have already know that sulfuric acid has a strong affinity towards water, so that it is used as a drying agent. The next one, it is used in the preparation of pigment and explosive. Test for sulfuric acid. The sulfuric acid is tested with the two reaction. One is when the sulfuric acid is added with the barium chloride, it gives barium sulfate and then HCl. You split the barium chloride as barium plus and Cl minus, barium 2 plus Cl minus, and sulfuric acid as 2H plus and SO4 2 minus. Then the barium 2 plus is reacted with the SO4 2 minus, we get barium sulfate as a precipitate, white precipitate, and Cl minus is reacted with the H plus, it gives 2HCl. The same way in lead acetate when reacted with the sulfuric acid, it gives lead sulfate is a white precipitate, and then acetic acid is the one of the product. If you get the white precipitate, means that given substance as a sulfuric acid. So we can test the sulfuric acid with the help of above these two reactions. The next one, structure of acid, sulfuric acid. There are different type of sulfuric acid. First one, sulfurous acid. Formula is H2SO4. This H2SO4 contain 1 sulfur, 3 oxygen and 2 hydrogen. So first of all, we start with the sulfur. Sulfur is present at the center. Around that you put 3 oxygen, and the 3 oxygen, one of the oxygen contain double bond, and other 2 oxygen, it contains only single bond because it form single bond with the other 2 hydrogens. So that the structure is, see that sulfurous acid structure. The next one, sulfuric acid. Sulfuric acid is H2SO4. It contains one more oxygen than sulfurous acid. So in sulfurous, refer the sulfurous acid structure, we have to put one more oxygen. So the center sulfur, it contain double bond, it form double bond with the oxygen. It is a sulfuric acid formula structure. Based on this sulfurous acid structure and sulfuric acid structure, we are going to see the other type of sulfuric acid. First one, thiosulfuric acid. Formula is H2S2O3. This H2S2O3 we can consider as the sulfurous acid contain one more sulfur. So you first of all draw the structure of sulfurous acid, and one more sulfur is added with double bond with the central sulfur. The next one, dithionous acid. Formula is H2S2O4. We consider this formula is H2SO3 is contain SO4 extra H2SO3 plus SO. So first of all you draw the sulfurous acid formula, and it contain one more SO. I indicated in red color. SO means S double bond O. The S double bond O is you put at the in between the OH and then another SOOH. The next one, disulfurous acid or pyrosulfurous acid. The formula is H2S2O5. You consider this one as H2SO3. Sulfurous acid contain extra SO2. So in the structure, you first of all put the sulfurous acid formula, and then SO2 I indicated in red color, we have to put in between that. Remaining sulfuric acid formula structure is given here. Disulfuric acid or pyrosulfuric acid formula H2S2O7. We are going to consider this equation as sulfuric acid contain SO3, that is plus SO3, sulfur trioxide. So first of all, remember the sulfuric acid formula, sulfuric acid structure. Along with that, we are going to implement the SO3. SO3 I indicated in orange color. SO3, it means sulfur. It contain double bond. It form double bond with the oxygen, 2 oxygen, and single bond with the 1 oxygen, and also with the another oxygen. The next one, pyroxymonosulfuric acid. Formula is H2SO5. H2SO5. This contain H2SO4 and one more oxygen. So first of all put the sulfuric acid structure and you have to put one oxygen in between that. I indicated in orange color. The next one peroxo disulfuric acid, and then another name is Morsel acid. It is one word question, girl, remember it. And its formula is H2S2O8. So we can consider this one is a sulfuric acid contain SO4. So I indicated, first of all you put the sulfuric acid structure, in between that we have to put the SO4. See that SO4 how it is implemented means, first sulfur, it contain two double bond with two oxygen, and two oxygen we are going to put at the center. In separately we have to put it the center. The next one dithionic acid, formula is H2S2O6. We can consider this one is a sulfuric acid along with the sulfur dioxide. So you have to put the sulfur dioxide in between the structure of sulfuric acid. I indicated in orange color sulfur dioxide. How can we put it? The sulfuric acid means sulfur, it contains two oxygen with a double bond. The next one polythionic acid, it is same like dithionic acid. One more thing is the sulfur with N sulfur is added with the at the central. So the polythionic acid formula H2NSN plus 2 O6. It contains sulfuric acid, sulfur dioxide and SN. We are going to just imagine this one is a sulfuric acid, sulfur dioxide and N mole of sulfur. So that we have to first draw the sulfuric acid formula. In between that we have to implement the N sulfur and then sulfur dioxide. I indicated in orange color.